Okay, on this example, we're given a demand function, given a supply function. We're going to try to find where these meet up. That's going to be referred to as the equilibrium point, where they're equal to one another. Along the way, we're going to find the equilibrium quantity, the value for X in this situation. We're going to use all this to find the consumer surplus. The formula is given down below. So as we get going on this, we want to know when are these two functions equal to one another. So we're going to say 338.8 minus 0.4x squared is going to be equal to 0.3x squared. Now to solve this one down, I'm going to move the x's all to one side. So I'm going to add 0.4x squared to both sides, leaving us with 338.8 equals 0.7x squared. We're going to divide both sides by 0.7. Therefore, getting the x squared on one side by itself, making this a power equation. This turns out being 484. As we apply the square root to both sides, this is going to turn out being 22. I didn't worry about my plus and minus out there because we're only going to be selling a positive number of items or producing a positive number of items. That's our equilibrium quantity. Next, what we want to do is find the equilibrium point. So we're looking for an x value and an output. So this is a quantity. This is a value for Q. In our formula down below, we use Q star to represent that. We need a price to go along with this. So what we can do is either plug into the top, the demand function, or the supply function. They should result in the exact same output. I'm going to elect to plug into the supply function because it's a little bit smaller, shorter. So 0.3 times 22 squared. And this is going to turn out being 145.2. So basically we have this ordered pair that goes 22, comma 145.2. All right, next up, let's use this information and set up our consumer surplus equation. So we want to find the integral between 0 and 22. And then we're going to copy down d of x down here. So that's 338.8 minus 0.4x squared. This will be integrated with x minus, now we want to say p star, which was 145.2, multiplied by 22 q star. That's our equilibrium point, p and q. All right, now let's go about integrating this. So integrating one term at a time here, we have 338.8. A constant is going to get an x with it, plus 0.4, bringing the constant along. Next up, I'm going to increase my exponent by 1 and divide by the new x by our exponent. This should still remain a subtraction. All right, this will be evaluated between 0 and 22 as our bounds of integration. And then we're subtracting away. As I multiply this out, I get 3,194.4. All right, next up, we need to fill in our bounds of integration. So we have 338.8 multiplied by 22 minus 0.4 divided by 3 multiplied by 22 cubed. From that, we're supposed to subtract 338.8 multiplied by 0 minus 0.4 divided by 3 multiplied by 0 cubed minus 3194.4. Now, when we plugged in the 0 times anything is 0, so all of that turns out being 0. All right, so really we just have to worry about this computation minus 3194.4. And this works out to be 2,839.46 repeating dollars would be our consumer surplus on this problem. All right, hope this helps out in setting this up. Remember, at equilibrium point, set them equal to each other. After you get that value for your quantity, Q, you're going to plug that back into one of those functions, therefore getting you a price. After you have P and Q, you can fill into this consumer surplus equation and work it down. Good luck.